Good evening to one and all present here. Today we have a special guest, Mr. Rajen Dasgupta, who is an innovation manager at IIT Dhanbad, a mentor of change at Atal Innovation Mission, and founder and CEO of Kiri Robotics. Over to you, sir, for telling us about introduction to industrial robotics and its benefits. Sir, are you there?
Yeah.
Yes.
Thank you,
yes.
Rishabh.
Yep.
Okay, let me share my screen up. So very good afternoon to all of you. So today in your Dhruva, that's a Tech Fest by IIITK, I am really very glad to present some of my experience and some mentorship experience and whatever I have experienced in IIT Dhanbad, I would like to share with you. And also I will discuss something, introduction about the recent trend of robotics. And inside that we will discuss more about all the latest technologies. So, so recently I am innovation manager, as Rishabh told that in the IIT Dhanbad. We are mainly focused on the innovation part, not only, but we are also try to grab the budding entrepreneurs and the innovators who would like to contribute their ideas in the society. And we also provide them support in terms of mentorship and your financial support. So later on, I'll discuss this thing in detail. So let's start. So today's topic will be the introduction of industrial robotics. So this is my brief profile. Okay, as you know, our topic in this fascinating things, and everyone is quite interested when we talk about robots. So today's I will discuss about the different types of industrial robots, where we will learn what exactly industries are looking for from the students and from the company point of view. So as the industrial robot, we are concerned that these are mainly used for application like assembling the you can say parts or any automobile stuffs like welding, painting, assembly, pick and place. These are some common stuffs. And as you know, robots and machines, they cannot give you the inaccurate data. Whatever you will program, it will remain same. But although at the time will goes, as you know, nothing is 100% efficient. So you have to be like give some maintenance over there. So after introduction of the industrial robot in the market, if you can see 70% of the manpower is all gone, because industrial robots are giving them a more production rate and more accuracy in the industries. As in India, most of the automobile industries are equipped with the model industrial robots, and some of your medical fields, you will see the biomedical industries and your food industries. They are also going to adopt these things, because as you know, if humans have some limitations over there, but there are some contradictions that it will also give some unemployment generations, but it's not like that. If you are going to be employed, but you have to increase your skills in that particular field. So as you are all in BTECs and all engineering students, so I will my personal opinion is that you have to build your skills first. Your CGPA and everything is in the secondary part. So let's talk to the next part. So there are industrial robots are mainly divided in main 5 domains actually. It depends on the applications. Okay, what kind of application we are looking for. Suppose let's start with a Cartesian robot. As we all know, Cartesian robot is one of the basic robot which is having a three axis X, Y, and Z. Okay. So this kind of robots, or you can say application, you will find in the 3D printer that you already using in your labs and all. In 3D printer, we have X, Y, and Z axis. So this is a simple example of Cartesian robot. So if someone asking you the example, so this is a basic example. In this Cartesian robot, you will find the three motors actually. Mainly in this kind of small robots, we are using stepper motors where you need a high accuracies. But if you're going for the payload capacity, I will discuss later on. So in this Cartesian robot, you will find three type stepper motor, depending on the payload what you are using. Generally in Cartesian robot, we are preferring 1 kilogram of the payload, but your application is much more bigger. You can increase the payload as per the concerned motors. So in this robot, you will find the three axis X, Y, and Z axis. It will rotate. It will move in the translation positions X and Y and Z. So let's talk to the next one, that is SCARA robot. SCARA robot actually you can say it's also called an articulated robot. It's also having three axes, but the application is quite different. These are quite, you can say, sensitive robots, and their payload is less than 200 grams. Like these robots are mainly used for pick and place. So these are not that much highly accurate, but this will give you the application for pick and place of the equipments or whatever the tablets, what medicines you are using in the biomedical field. These robots are mainly used in biomedical industries where you have to handling the small parts, like in the sensor industries where you have to calibrate with the small sensors. You have to put the sensor in that like that, and you have to hold the soft thing. Where there you have to use SCAR robots. These are not that much costly robot, but they are highly accurate. As you have seen in lens cards last year, they have introduced some robotic technique to make the lenses. So they are using SCAR robot in their industries because, as you know, lenses are made of glass, so they are quite light and fragile. So you have to handle with care. So next part is your articulated robot. That is one of the, you can say, robust and huge machines. In that articulated robot, there are more than three axes, you can say. So these are actually universal robot as in our industries right now. Everyone looking for this kind of robot because in articulated robot, there is a maximum reach. In today's industry, you will find a maximum of 6 degrees of freedom. That it means that robot is having 6 motors, individual motors, and that is connected with all the links. So it can move in 6 independent directions. Suppose if you are going to make a, you can say, globe, that robot is quite useful for that. And it means it can reach entire space, like 360 space. So these are actually, you can say, costly robot and robust robot, and these robots are used in industrial purpose, basically in the automobile sector. They have the payload of maximum of more than 100 kilograms. And even one company in Germany, they have introduced one robot that can carry around 2000 kg of payload from their end effectors, like from their last point. That's why these robots are used in industries. They are holding the cars and they are holding some huge motors and engines with this. In this motor, you will find a servo motor, but this robots are using stepper motors because there you need an accuracy plus low payload. But in this articulated robot, you cannot use stepper motor. You have to use servo motor because servo motor is one of the powerful motors and which is having a locking mechanism. Suppose if you are holding something and you have to get that product in and you have to put it in the 90-degree positions, that robot is capable to hold that huge product and they can keep it that in a particular, you can say, angle like 90 to 45 degree. So that we can calculate using formulas. So this is a universal robot in the industry right now. Though it's have maximum of 6 degrees of freedom. That it means 6 axes. I will discuss what are the axes in this. So let's come to Delta robot. Delta robot, again, it's a soft, delicate robot. These are not made for the high payloads. These are maximum 10 kgs of payloads. These robots are mainly used where you need a speed pick and place, high speed. Like some equipments are coming in your assembly line and you have to pick and place in high speed. That robots are used in that place. And the Delta robots are quite actually not that much practice and it's quite costly. That need huge maintenance. So in that place of Delta robot, some are using SCARA and Cartesian. But in the terms of speed, Delta is higher speed. But due to cost, people are not concerning. So this is now let's come to collaborative robot. Collaborative robot, today we'll discuss in details about that. In collaborative robot, these are high accuracy and new generation robots. These robots actually called, you can say, human machine robot. These robots are, you can they are interact with the human being. These all robots are all programmed. This is also programmed, but these robots have some integrated external sensors. Like this robot, you can guide from your hand. If you can move that robot with your hand, it can learn. And that if that robot is working something and you touch accidentally that robot, it will automatically stop. It won't harm any human being. That's why these are called new generation robots. That's collaborative robot, also called cobots or co-robots. There are two names. These are quite costly these days, but in coming year it will become a really familiar. And in cobots are more than 3 axes, just like articulated robots, but these are having a human interface. These articulated robots are quite dangerous because when they are in running position, if someone entered that area, that robot can harm that person. In this last year in Germany, something happened in the Mercedes industry. One person accidentally entered that working zone of the robot, but that time robot hit the man and that man was no more actually. So this that accidental point of view, collaborative robots are quite better, but there are some disadvantages that collaborative robots are not that much capable to lift the heavy weights because they're just recently launched in the market. The company has not yet invested that much money to that can hold maximum of 1,000 or 2,000 kgs of payload. In market, you will find this cobots a maximum of 50 kgs of payload maximum as of now. And cobots are really fast. They can move at a speed of 5 meters per second. And these are quite smart, you can say. Let's come to the next slide then. So these are Cartesian robot as I already discussed. These are having a 3 axes, X, Y, Z axis. These are only this robot will work in single translation positions like C. But if you want to put that thing in this wall, it's unable to put that thing. Okay. So there are some limitations in the Cartesian robot. Cartesian robot is only used to move the pallets or your articles in just one linear position. That's why only pick and place. That's linear pick and place. Like as I told you in 3D printer. Now this is one of the SCARA robot. These are quite delicate robot, and these robots are used to hold the soft, delicate objects. Like these robots are mostly used in biomedical technology industries. So these also having XYZ axis, but quite delicate and low budget robots, in which that can hold a soft material. Now, this is articulated robot that I told you that one of the heavy duty robots. These are, they have 6 degrees of freedom. See, they are one axis. This is one axis. This is second axis. This is third, and this one is fourth, and there's 5 or 6. There are total 6 axes. Standard 6 axes are there, but afterwards some companies are introducing 7 axes also. But there is no robot with more than 7 axes as of now. But in its industries, maximum 6 axis robot is using in. So these robots are same function, that they can do the assembly part, they can do arc welding, they can do material handling, they can do machine training, packaging, everything they can do. The problem is that they won't, you can say, help the human being. When something happen, they will like, I will do my work. If something come, I will break that thing. These were the heavy duty robots. They can lift more than enough weight. So this is actually about articulated robots. And these robots are using AC servo motors. So these are 3-phase servo motors. As you know, servo motors are one of the powerful motors which can hold and hold the objects and in particular angle with high accuracy. Let's come to the Delta robot. See, this is the movement of the Delta robot actually. In Delta robot also you have 3 motors. These are servo motors. It will move in just like, you can say, circular positions. Okay, it can reach its reach area is circular motion. Okay, it can reach in that entire area. So where you need a fast pick and place, there you have to use this. So these items, these robots are using all the small industry, like where you are using some small product, like you can say tablets or medicines, like electronics industries, where you have to put some electronic components on the PCB board. These robots are really helpful for that. So another name of this robot is a parallel robot actually. And these are quite trending and quite costly. That's why people are not that much familiar with this robot. In India, you won't find that much Delta robot in the industries. Mainly those, they are preferring articulated robot. Articulated robot are cost effective as compared to these robots, and in the terms of maintenance also, articulated robots are low cost maintenance. And in the Indian market, it's just from since last 10 years, the Indian market is made for the articulated robot as of now. In the coming future, it will come for Delta robot also. So this is actually collaborative robots that I discussed. These robots are really, you can say, human-friendly robots. This robot won't harm any person. You can teach them how to move. And when someone come inside their area, it will stop himself, and also not only stop it, they will slowly reduce the speed, because in this entire body you will see there are lots of human machine sensors are incorporated in the entire robots. That's why the cost is quite huge. In this robot, you'll find a maximum 7 axes actually. 6 to 7 axes are there. Again, these robots are used in all purpose, because in any robot, if you find more than 3 axes, it means that robot can reach a maximum of entire space area. In the sphere, like articulated robot has 6 axes, that robot can reach maximum area. Means wherever you are putting your objects, it can pick and place in that particular angle, particular flooring, wherever you want. And cobots are quite safe in that, you can say, in terms of safety purpose. Okay, and in terms of payload capacity, these are costly. As of as if you compared with the articulated robots. In articulated robots, if you are going to purchase articulated robot for 1,000 kilograms, that cost around 5 crore. Okay, but in terms of this robot, if you're going to make that kind of huge machines, that cost around 50 crore. So there are huge cost difference. But if you calculate in terms of the payload capacity, cobots are really good because they are equipped with multiple sensors. Again, these are used for multiple purpose. There is no such limitations in this. It can also do pick and place. It can also do palletizing. It can also do painting. It can also do some, you can say, any delegated things. Only you have to change the end effector. Means last gripper you have to change. So let's learn about more about, because here in the presentation I will discuss about the cobots in details. Because as you know, cobots are really fascinating and new generation robots. You have to know more about this. So there are some, see, this is the cobot video. I'll share. These robots are really designed for the delegated things. They have multiple sensors. They know how to hold which object. Means if you say this is a glass, this is a bottle, so they will give that much pressure. So in the entire body, you will find lots of sensors, like pressure sensors are there, force sensors are there, obstacle avoidance sensors are there. Multiple sensors are equipped in this entire robot. As you know, the company KUKA is one of the leading robot manufacturing in the world. The company is from Germany. There are some features of cobots which I already discussed. See, these are some features: power and force limitations. Each joints have their some force sensors, as I told you, so that can prevent the accidental damage of the human being. And also, there's a hand guiding option is also there. If some delicate application if you want to do, you can just hold the robot and you can move that robot. It will learn the motion, how you are moving that robot. This is called self-guiding techniques. These cobots are really intelligence, you can say. Whatever you will say, which path you have to follow, they will follow that particular part. And one more thing, they have some speed motions also there. As I already discussed, if something have come in between their workforce, it will automatically reduce the speed, and even they can also stop. Again, when the object will move, you can take the object to again resume from that particular position. They also, you can say, these are quite smart robots. So there are, in the terms of safety concern, these are safe velocity monitoring. This robot, as I discussed, this robot will monitor the velocities, safe workforce and safeguard zones. So safe collision detections due to incorporation of lots of sensors. As I told, this pressure sensors are there. There are lots of proximity sensors are there. and even dust sensors are there. There are lots of sensors are in tube. The safe force and monitoring. So this is actually quite an interesting point. You can say avoidance of pinching or crushing. If something happens, suppose you put something in front of the robot, it will hit that object. That's sure, because without hitting it, it cannot detect. But it will also sense what kind of material it is. So that particularly he can give that much force. Like I have seen you that video that robot is holding the glass. So he first they will press that glass, or you can say metal glass, whatever you are holding. They will automatically sense the pressure, how much they have to put, because glass has their own weight, right? So in terms of weight, it will apply the force. Suppose if you are giving them heavy weighted things, but that in that case, he will apply up the required pressure to hold the glass. So this thing is completely depends on the weight, the payload, what the robot is holding. And next point is safe tool detection. As you know, robots are used in multi-purpose, so you can change the tools. Like if you are doing welding stuffs, if you are doing for screwdriving, if you are doing some painting. So these are actually out end effector is called tools. Screwdriver will be tools, your wrench will be your tools, whatever you are putting in your end effector of the robot. So all see in this robot what will happen. Suppose if you are going to tighten some screw, but that robot is holding some different tools. It won't it's not going to tighten that screw with that range, because it will find the exact positions, whether my screwdriver is inserted in that particular screw or not. That thing can be easily detected by that robot. That's why we are calling this a smart robot. The entire process is designed in such a way that it will detect the pressure and force of that end effector, whether it's screw or whether it's glass, whether it's ball, it's holding, whatever. And next is your safe switching of state. So this is the basics, you can say, in this. It's happened in all the robots. There are some safe zone are there. As I told you, in every robot there is a maximum reach is there. Suppose your robot length is 5 feet, so it will reach a 5 feet of area, like radius of 5 feet. So you will make a circle from entire 3D space. So that will be his working zone. Okay. Beyond that, we will add some space that is called protection zone. Because after working zone, where the robot will reach maximum positions, limitations, that are called a protection zone. And after few meter, that will be a protection zone. If someone cross the protection zone, it means that person is in danger position, because now robot is moving. If the robot is holding some object, then that object will go behind the protection zone. But that means the person is in vulnerable conditions. But in that case, these robots are used in such a way that this robot is not going to harm that person who is in the protection zone. But in the case of articulated robot, that person will get harmed, because robots are not equipped with any kind of sensors. There's no collision detection sensor, there's no force sensors, nothing like that. But this kind of features are available in your cobots. So these are all safety related stuffs, where whatever companies are manufacturing the cobots, they have to follow this kind of safeties. Okay, they have to use some safety standards. As you know, industrial development going on. So in our industrial trend in 21st century, we are equipping the robots. As you know, robots are not a new thing. They are since so many decades we are using the robots in multiple ways. But in today's generation, we are equipping the robots with latest technology like your IoT, big data, machine learning, AI, cloud, and all. So that's why we are now our task and our companies R&D sectors are working on the advancement part of the robots. They are not doing any research work. They are not doing any modification of the robots. They are putting the advanced and intelligence part in this 21st century robotics industry. So in this, how you can add that much sensor that can, because as you know, in today's industry 4.0, this is all about your cyber physical system, that is called, you have to use the entire setup in sensor mode in digital format. So that's why in this trend you have to, and the companies are doing that much high accuracy and high tech techniques to make their robot that much intelligence that can give their more accuracy, more powerful in all the aspect. They are making these things in powerful. So this is actually some example of cobots actually. So how actually they are doing. Earlier cobots, how it happens. There was first, I will see you this. The first you can observe this image. In this image, this is your cobot, and this is a human being. Okay, but in between that there is a, you can say, light detector barrier or any laser light. You can say that this kind of light they are using earlier days. Once the robot will cross this line, this laser line, it will detect, it will sense the robot. If some person is going to put their hand in this laser light, again that will give you some sort of indications, and that indication will stop the robot. It will act as a, you can say, switch. Earlier that it was practiced, but after that, due to means implementation of the lots of technologies and advantage of the sensors and AI machine learning, then again that what happened, they have done something like that. Next part, they have put fixed wall. There is no lighting, nothing. Robots will work here, person will work here. Just between these two, how to minimize the gap between robots and human being. The new generation of robots are introduced like this thing. Okay, so in this, what we have done, we have equipped the intelligent sensors in the robots itself. Earlier, we are using sensors in the walls like laser sensors. Here we can touch sensors, but we can contribute this thing in the entire robot. Now, robot is equipped with your sensor, so you don't have to use any particular barrier in particular fencing for that robot. So in this case, you can see the person is there who is touching the robot, but robot is not going to harm that. Okay, so in this case, what happened, the robot can be guided by the human being directly. So this is a quite interesting thing. But in the coming future, I think something will happen, some more advanced thing will come. This is all about the generation of cobots. Now, these are some benefits of cobot actually. So, as you know, robots are simple, repetitive handling tasks. Human, on the other hand, have cognitive skills, understanding the task. The combination of humans and robots can greatly improve performance as long as they work in optimal shared. So this is quite interesting line actually. As in cobots, humans and robots both are working in that close relations. In other robots, what happened, you have to just program the robot using your remote control or using the some much some teach pendants they have. But in that case, the accuracy is not up to the mark. But in the case of when you are holding the robot and you are putting that robot with your hand and carrying the robot in the particular positions, means it's like you are holding your pen and you are writing something or drawing something. It's something like that. So it's like if you are holding some pen with your hand and you are holding that pen with some stick, which is more accurate, like holding a hand pen with your hand. So it's something like that. That robot is in your hand. So that can give you more accurate in all sort of the directions you can say. And as you know, these robots are quite, you can say, softly designed. It won't harm the human being. There is no hazardous nuts, bolts, nothing like that will harm the human being. These robots are quite soft, and outer bodies mainly designed by the fiber bodies, so it will be quite soft. But the internal structure is designed in such a way you will find lots of sensors and all. So I'll show you the entire design of the robot actually. See, this is the entire robot design of the robot, what that person is holding. So these are multiple sensors actually. If you'll see there in the entire body, there are lots of sensors. Sensors and there are some motors are there. In this robot, there are 7 axes. This is one axis, 2 axis, 3 axis, 4 axis, 5, 6, and 7. In this robot, you will find this total 7 axes. Means the entire robot is divided into 7 parts. That is called 7 degree of freedom. The degree of freedom mainly is called independent movement of each joints. Like in our hand, we have 3 joints: shoulder, knee, and your wrist. Similarly, this robot has just 7 joints, so that they can reach a maximum. Not maximum actually, they can reach a entire space, not maximum actually. Whatever you want to reach, that robot it will reach. So let's come to again the back slides. Yeah. Now, industries are using the open source platform to program the, as you know, robots are as a machine. They have the in main part of the industrial robot is the motors, because without motors, appropriate motor, the robot is not going to work up to the mark. So first, initially, industries are choosing the how much payload I have to develop. So that's why accordingly they had going to choose the particular motors, as in uh, most of the robots we are using the servo motors, and few Scala and Cartesian we are using stepper motors, where you need a high accuracy and low speed and low payload. But where you need concern more payload, you have to use the servo motors. The next part, once you selected a servo motors, you have to choose how to program that servo motor using some controller. So all the industrial robots are equipped with one CPU that are called microprocessor they are using. So they have their own. Some are using little Linux board, some are using Windows board. So like this kind of things they are using. First then once they are choosing the motors, they have to choose the PC where they will do the programming part. Then after that they develop some firmware, then they develop some user interface softwares using some open source platform. They are not directly using the open source for their development. They are means they are using open source, but they are doing some tinkering on that. Like as you know, Android we are using that are completely open source platform. But the companies like Samsung and other companies that OnePlus, they are using Android, but they have designed that Android in such a way that it's like they give their name. So it's an Android bus, but they have given some modification of that. So even suppose if you are doing some projects in your college or somewhere, so you can also use open source. I will suggest always choose open source because it is a wide branch, and there are lots of resources available, and there is no limitation in the open source platform. but don't use it directly. Change as per your requirement. Like I will give you some example of the open source platform. As you all have seen the Amazon Alexa. It's a Amazon product. They are doing quite number of great business in the market. But if you can go through this Amazon Alexa, it's a open source. It came from an open source platform. That you have you heard of this Raspberry Pi? They are using something like that. So they have done? They have took the open source resources and they have modified as per their requirement. Now they can call it as their own product. So like similarly, the industries are doing. They are pick up the ROS OS. They are not going to choose a OS which are mm, proprietary by some company like Windows and Linux. They are not directly using. They are using ROS and they are just converting those the things up to their requirement, and the items which they are not required, they are not using all those things. Okay. So similarly, after that they are going to design their on all software APIs and these things. So in the entire robotic industries, they are focusing on this kind of platforms. So we will sometime, if we get time, we will discuss further more about the how the architecture it was. Okay. As you know, in the market is quite increasing in the field of robotics, basically industrial robotics. There are lots of robotic branches there, like you can say medical robotics is there are social robotics is there. But social robotics are like only for fascination purpose, like your robot which got citizenship in the UAE, that is Sophia. These robots are just for sophisticated things. There's only company will get some fames and all, but there is no that much revenue for that robots. But if you come to the industrial robot, they are huge market revenue and there are huge demand in the market. Because all the industries are and all the factories are converting into digitalizations so that they can give their higher production rate and higher accuracy in terms of in this competitive market. So similarly, if I'll compare with the data like which published in the last year, that in 2017 it was like 450 gravity robots. So now it's like 12,000. There are huge changes. If you can see in the 7 to 10 years, they are huge going to change. So the industrial robots are really changing drastically. All the small, even some small factories are also converting into the automation part. Some are using robots, some are using CNC machines. Like as you know, I told you, CNC machine is a type of robot. They are called as Cartesian robot. So ultimately, they are choosing the robotics field for their development and for their market growth. So as I told you, this is a sensor integrated. In this robot, which I have given you, this is a robot designed by the KUKA, Germany-based company, is a leading manufacturing in the world of robotics. In this world, there are only 4 to 5 companies. They are leading in the market. That's KUKA is one of the robotic company, and second is ABB, that is from USA, and Fanuc is from Japan. These are 3 giant manufacturers of the industrial robots since so many years. And recently, there are some companies like Yaskawa is there, and there are some Delta robot is there. There's few companies are coming in the market, but these 3 giants are since from last 50 years they are in the market. And as I told you, this is a cobot manufacturing by the KUKA. They have a 7 degree of freedom. As I told you that there are 7 degree of freedom means there are 7 axes. It means 7 motors are there. This is 7 motors, 1 motors, 2 motors, 3, 4, 5, 6, 7. And payload is 4 to 17. As I told you, cobots are not made for heavy duty purpose. As these are new generation robots, these are just right now for the, you can say, research purpose. These robots are still in research mode, not that much intelligent as of now. People are doing research in their PhD or MTech programs, so that they can explore much more about the cobots. How can they will make design in such a way that it can hold a maximum payload. So this robots are mainly used for the small stuffs, and this is a payload weight ratio is 0.07. It's quite good. But in the if you go to this ratio in the terms of articulated, it's more than 1. And accuracy, see, this is 0.1 mm replicability. So this is quite decent accuracy. I think it's a negligible. It's a highly accurate robot as compared to the other robots, because as I told you that this robot is just like you are holding a pen in your hand. So that is accurate. If I told you to like similarly that if you're not holding the pen and you are putting that pen in some sticks and you are drawing, that will give you less accuracy. But in this case, you are controlling the robot with your hand. Means you can guide the robot in such a way that it will be that much accurate. And when 0.1 means it, how many times it will do. Suppose you are going to do some task like it will pick the object A to B. Okay, then this robot will keep on picking A to B, A to B, A to B, A to B 1,000 times. But ultimately, you will see the accuracy is 0.1 mm. Even human being cannot do this thing. It's an impossible thing for a human being to give that this much of accuracy, even with some single, without any repeatability. But with repeatability, they are giving this much accuracy. So this is quite decent measurement actually. So, and there are some sensors are there, as I told you, torque sensors are there. Torque means it will detect the pressure and force. So a part of that torque sensor, you will find the collision detection sensors are there. Their touch sensors are there. There are force sensors are there. There are multiple sensors equipped with this, and some industries and some researchers, they have purchased these robots for the development in this cobots. As I told, this is in research mode till now, not yet in the market fully. So some people, some researchers, some scientists are doing some research that how can they will inbuild much more sensor, how they will give them much more accuracy and much more smart product with this. So let's go to the next slide. Is a wide application of the cobots. These are mainly wide applications. There are lots of applications there. As in the industrial robot, assembly is one of the biggest application for entire robotic change. Entire means whether it's a articulated robot, whether it's Stara or Cartesian or cobots, assembling is the important applications in this entire industry. Means people are choosing robots because the process will get faster. If something some human beings are doing some pick and place, some human beings are doing some packaging and all. So this thing complete done by the robots. Like in the automobile industries, the cars is manufactured and the trucks are manufactured. So they have huge multiple, you can say, assembly line. They have multiples robots in there. Some robots are putting the engine, some are holding the door, some are doing welding, some are doing screwdriving, whatever. There are lots of, you can in single assembly line, they are putting more than 20-30 robots. They are doing multiple tasks as per whatever they have programmed. So this is a huge application. And next, you dispensing. Again, it's a part of the automobile industry. They whatever the car you're purchasing, this is all the painting and polishing is done using the robots. Because if a human being concerned, they are not going to give that much accuracy, that much quality to that task. And gluing, sealing, everything is done by the robots. And this is finishing and sending polishing. Again, this is the same thing. So human are not allowed to do that. If they are doing, they will take a much more time, and that then you will see that difference in the results. If something, some human beings are doing something in today and they will do something different tomorrow. So this it can changes. So in somehow the quality, if quality will change, the company won't compromise in the quality anyhow. And this is your machine trending. These are CNC injection mold. These are things. And next, your material handling, as packaging is done using robots. Palletizing is done in the robots, like in the Amazon warehouse. You will see in India, in Gurgaon is there. So in Amazon warehouse, even in South also there, Bangalore. In that warehouse, you will find a multiple robots. They are engaged in such a way that this huge workshop and warehouse are designed that whatever your things are, is counting and stock maintenance, everything is done by the robots. And your material removing, like grinding, debugging, milling, routing, these things are just done by the robots. Because robots, this thing actually not particular robot, this again it will comes in terms of CNC machines. As you heard, that CNC is one of the fascinating device in mechanical department. So again, CNC is a types of, you can say, Cartesian robot. They works in X, Y, and Z axes. CNC mainly works in X, Y, two axes, but tools is act as a Z axis. Again, advancement of CNC is a VMC machine. They are completely 3D axis device where you can remove. Suppose if you want to make some sculpture from a material, then you have to take some cuboid, a cube like metal. Then that CNC or VMC machine will remove the material and it will give you a final sculpture design. Then quality inspections, testing, inspection, and measuring. That is again done by robots these days. When there are some just moving robots are there are some stationary robots are doing, depending on the purpose and application in the industries. This is again welding, arc welding, soldering. This as I told you, soldering that your Delta robot is doing this thing kind of things also, putting the component in the PCB board, and some robots are doing the soldering part. In arc welding, this welding is done in the industry of automobile, where all the automobile parts are get welded by the robots in accurate way. And there are lots of other applications, like in some of the industries where you can say food packaging industries. Some robots are used to cut the meat, some are used to cut the huge you can say food materials. These kinds of robots are also used in food manufacturing industries. There are also even some industries are also doing some sculpture and wall painting using the industrial robots. So these are small examples. Suppose I think in internet you might have seen some robots which are doing some 3D printing on the wall using robots. That can also be done. And some robots are deployed in the military sector also. Let's come to the next part. See, these are some application of cobots in the industries. See, this is a reach actually. This robot can reach anywhere, like we can reach. It's a 7 degree of freedom. So there is no limitations of reaching the place for these robots. Now, cobots are designed in such a way that they can synchronize with other robots without any programming or like something like that. Okay, because some research are going on, these robots will internally connected with the IoT platform, so that there is no need or any particular programs to do that. See, this is a goodness of this robot. They can try to fit the object. If something stuck, but they will keep on trying. Why it's stucking? Like a human being. If we are putting something in some hole, but that thing is not going inside, we wish to keep trying. Why it's not going? Similarly, the cobots are that much smart. They used to keep some extra pressure so that that material should go inside that. Okay. Okay, then I will discuss something more about our tech spin and all. So first, ask your question if you have some questions. Afterwards, I will discuss some different topic on that. Okay, then let's come to this one. So here, as I put some logos over there. So as I in IIT Dhanbad, we have designed a TechSmin Foundation. That is a, you can say, company called for mining purpose, where we are supporting the young budding innovators and entrepreneurs, those who have some ideas for developing okay. So we have got one question actually. Let's take the question, then I'll discuss afterwards. Yeah, there's one question: is there any future of cobots in more common areas of use, like for food production? Yeah, there are huge market for these cobots in the food production in restaurant, because these are quite fascinating these days. In some countries like Germany and France, they have introduced these things in their particular restaurant. You can also try this, but in India it will cost quite huge right now. And in food industries, as you know, not only the cooking is concerned, all taste is also concerned, because in some uh, last year month meeting we have discussed regarding that it's not about cooking. You just only cook the style, the handles and all. It should not be like that. So you are holding, the robot is holding the spoon and turning the utensil. How will you measure the taste of the food? Because it's not like you will observe the robot is cooking. That is just for the, you can say, some entertainment purpose. But if you're going to open a food restaurant using some cobots, so how can you challenge that taste, whether it's tasty or not? How can you give that particular ingredient, how much quantity you have to add, whether the taste is good or not? For that, this purpose, some universities are working for that actually. This, as I told you, cobots are still in that much research purpose. They are going to integrate some machine learning and AI stuffs where they will detect the test, because again the test is not, you can say, fixed thing. It's a huge, mm, you can say, it's not a like taste. It's a countless actually. Every person have different taste, so you cannot measure the taste. But still, some scientists are working on the how can they will detect the taste using some sensors. So once this research will be completed, when something output will come, then you can incorporate this cobots, but particularly in the food production in the restaurant. Also, it will check the quality of the food. Okay. So let's come to the next one. Yeah, what are the microprocessor? Actually, microprocessor mainly used in the robots is not actually particularly fixed. It depends upon the company to company, and it also depends on the application what you are going to use. Like some companies are directly using Linux boards. Some companies are also using your Windows board like i7, i3 in customized mode, and some companies are again design their own boards. Okay, so these are not particularly fixed that you have to use this particular microprocessor. And when you can use some better, you can say development board like we have in our you can say Raspberry Pi we have. You can also use for a small project like for small purpose of cobots. You can also design your cobots, but that can not be that up to the mark for industrial grade. But if you're going for concern about the industrial grade, that again you have to design your own boards. Next question is a learning, and is a machine learning extremely used in board. As of now, it is not using, but as I told you, the machine cobots are still in research mode and research purpose. Is not yet actually completely deployed in the industries. So that's why the machine learning keeps still going. They are users are using the robot because industries, those who develop the cobot, they have given this cobot to the industries, different industries, just to check whether what are the challenges they are getting and what are the problems they want to solve with that cobots. Because when the manufacturer doesn't know what are the means benefits they will get it from cobots in the market. So it's still in the research mode. So whatever the users are doing, they are also working in the machine. Completely, they are working in a machine learning mode actually. Whatever the things, what are the failures? It's not machine learning. It doesn't matter that the robot is working. In machine learning, they are collecting data for the failure, accuracies, and the sensors. So this all the data are getting collected by the different users. In the coming futures, this data can be again retrieved and give you some better values of final results. So any other question anyone have? Okay, then let's come to this part actually. So okay, let me tell you one more thing actually. For robotics part of you, so the robotics itself is not concerned singly, but you have to much more focus on the automation part also. Okay, because robotics is completely depend on the automation part. Because as you know, industries is not particularly our in Indian industry. They are not robotics industry, although they are using the robotics as their one of the part. But this industry are mainly focused on the automation part. Because automation is a quite big branch where they are going to automate the product, means since from material procurement to final product. Entire system is converted into automation sector, where robotics is just a component in the automation, just like that. So you have to much more focus about the automation, what exactly industries is looking for, and what exactly industries are doing, and what kind of things you are going to implement using the robot. So in industry, robots are not being directly used by the particular task. So as I told you, robotics is just like a components, this like a helping machine for the entire automation system. And automation, if you're concerned about the automation part, There are some hydraulic pneumatics. These are some you can say kinematics. These are all things are equipped in the automation part. So robots, as the machine learning and AI is concerned, in there is not a single industry in India, not even in the world, they are using AI machine learning in this industrial purpose. But in the coming generation, they will use, because even industries and the manufacturer, they don't have that much data that how, what are the challenges, because machine learning is not a one day task. You have to, for machine learning you need lots of data for that to out get some good results. So this is a entire company chain, and in all the industries are using flexible automation system. Because suppose, as I told you, it's a company's concern like a Tata Motors, it's a company, okay, they have assembly line is there, they have a incorporated 20-30 industrial robots in the entire assembly line, okay, with using some automations like that. And in that same automation assembly line, they are manufacturing car like Nexa, they are manufacturing, they are also manufacturing your Harrier, whatever the car they are they have in the market. So just think how they are going to change. It's because doing a one program, because 40, how can you program entire 40 robots in that much accurate way, and all the robots are independent on each other, okay, sorry, dependent on each other. How? That is quite difficult, because in a car there are multiple sensors, multiple equipments are there. This is quite difficult for the industry to change the program. What they are earlier, what have happened, they have designed multiple assembly line, one for Nexa, one for Harrier, one for like that. But these days the industry has chosen one technique called flexible manufacturing, okay. In this system they have only one assembly line, and what they are doing, they have done something interesting, like only they have implemented a bit sort of, you can say, data collections. It's not actually exactly machine learning, but they have get some data collection, like they have chosen what are the common things in between the Harrier and Nexa, okay, like two cars, I'm giving example. So they have sought out the similarness, okay, and they have write this code separately. And what a different thing they have to choose, like Nexa is having a sort of program, and Harrier is having a B sort of program, and C is the common part of the both the car, and D is something again common part. So what they have done, they have give A and B aside, and C and D they have make it in the same program. Now, as per the market demand, suppose market is demanding I need a 1,000 piece of Nexa, okay. So just they have to program and install that A part only, not B and C, because as I told you, B and C is a common part. So they are not going to install. These are already incorporated in the assembly line. Only they have to put the A part of the program into the controller for the Nexa. So what happened? The entire your chain assembly line will design for that particular product. Again, in the coming future, some models is going to change, like they are required some different product. Again, they have to find the common thing in between the existing product and the new product. Then they have to write, get the data from the uncommon things. Then they write separate for code for that particular data for particular product. Then they have to install that code in that same assembly line. Again, what happened? That same assembly line will become a line for the different product. This is called a flexible manufacturing system. So in the today's generation, all the industries try to adopt this. Earlier, it was started from the Germany, but now in India, they are using, because the there are huge benefits for flexible manufacturing. For it will, may moreover it will give the huge cost cutting, because you the kind industry no need to invest that much money for multiple assembly line. So this is one of the advantage. Second advantage is it's a on demand assembly line. Suppose tonight you will get that tomorrow I have to deliver this kind of product in these numbers, but yesterday today you are doing some other product, but within one night how can you do that? So similarly, you have to upload the program for the uncommon parts, and that can be installed in your system. So this is some kind of thing you can say. So this is an advantage of flexible manufacturing. And in terms of a robot, actually in India as of now, there is not a single manufacturer of industrial robot. This is something not good for our India. But if you people can come forward and do something, because as you know, as I told you that there are three giants sitting in the entire world, not in India actually. So they are leading entire in manufacturing robot world of industrial robotics, KUKA, FANUC, ABB. And in India, almost 70% of the industries are equipped with the industrial robots, but none of the industrial robots are designed and manufactured in India. All are imported and all are, as you can say, assembled in India, not then manufactured. So even in India, those who are going to join the robotic industries, they will be like service engineers, not as a design R&D engineers, because there is no such plants where you will work. That is a really, you can say, not good for in this Indian market as of now. That's why people are moving to the Germany and US for that exactly manufacturing domain. But in terms of other point of view, like social robots and you can say defense robot, these things are manufactured in India. But in the industrial point of view, many things is concerned. Like safety is one of the major concern in this industrial point of view. That's why some companies earlier days, some companies have started doing some means manufacturing, not exactly manufacturing. They are doing 60% of manufacturing and 40% of importing, like assembly part. But the concern is the accuracy. Again, they have got some orders from the industry, but the accuracy is not that up to the mark. Then again, that company get collapse, and again, import system is still going on. But think about that if you can create some platform for the industrial robot in the as a industrial grade, not for the toy purpose. First, you have to propose that what exactly you are doing, because in industry, as I told you, accurate means safety is major concern. And second is your accuracy. With this thing, cost is a different thing, because see, cost doesn't matter actually. Industry have lots of fun. They have much more concern of safety and your accuracy. And third part is your service, because in industry you won't find that much technical guys who can service their own robot. Whatever the robots and automation system are installed in the industries, these all systems are, you can say, serviced by the service engineer, those who are coming from abroad and others. That's why those companies are from manufacturer companies are there in India. Those who are doing some setup in the industries, they used to hire the people from the Indian markets, and they used to train those employees to train the robots, how to maintain the robots. That's it only. They never discuss about the manufacturing part. So even in India, you will find lots of robot training institute also there, where you will learn how to train the robot, how to run the robot, okay, how to do programming. They are in robots. They are same language of is their C language. You can do the programming. So Python, in Python also you can do the programming. So this they used to teach them how to run and how to maintain the robot, but yet not no manufacturing. So you just think about it, and if you have some idea, you can also connect with me, because in IITISM we are funding the startups in huge form. Okay, all the innovators, starters. Mainly, we are here focusing on the mining sector, because in mining sector, what happened, because as you know, IIT Dhanbad is a domain for mining industries. We are looking for, not looking for the mining guy. We are looking for the technology for the mining. Like if you belong to the electronics domain, you can contribute your electronics idea, which can give some enhancement and advancement to the mining industry. So that if you can submit, we'll give you the mentoring support, technical support, whatever you support you're looking for, we'll provide. Because here government is giving that much, we can say, funding and supports to the colleges, that you, where you will get, you have to take the opportunity. Actually, once you will get the opportunity, you automatically will get your team and you will work on that. So even suppose if you are someone is from mechanical background, they can give some design, like a suit design, like a suit design, whatever design you, some failure design, safety design for the miners and the mining people, those who are working underground and open cast mine. And in the mining, there are biggest challenge is the communication, because till now in India there is no communication channel inside the ground in underground mines. So that is one of the biggest challenge, because without communication channel, like there is no Wi-Fi works there is no RF, nothing, because coal is highly, you can say, informative substance, so that they used to absorb the entire waves. So suppose if you are putting the Wi-Fi routers inside the underground mines, it will hardly travel 10 to 8 feet maximum. After that, whatever happen, you will find the waves are getting absorbed by the coals and all. So these are really biggest challenge. And then one more thing, there is no IoT communication, because recently we are going to publish one grand challenge for IoT actually. How can you implement IoT for the open cast mine? Like, as you know, mining is a huge area where you can install some device where you can observe the where is the blasting is going on, where the trucks are, where the sensors are there, the entire system. So these are quite big challenges in Indian market as of now. So just think and just try to get some idea over there and try to apply for that, because see, you are in that much, that age, that you can give your best, and you have that much energy that no one can give. So we are always open for the innovators and young startups, those who want to do some contributions to society and the for Indian market, because we are going to uh, change that tradition that we are still in the import mode and all. Okay, so you can directly mail me that whatever your design you have, whatever the plans you have. Okay, so then we will discuss, and we will also, it's not like you are going to give a perfect solution, but we'll also suggest you to make the changes. We will also provide you the entire lab setup, entire research lab, whatever you are looking for, we will provide that. And then we have huge support from the NITI Aayog, we have huge support from MSME and your Taxman Foundation, that is uh, sponsored by Science and Technology Department of DST. Even IIT also, the robot is also going to fund that much. So okay, so this is all about a part of course. This is for your career actually. So come forward and give your some fruitful views and ideas and share with us. Then we'll let you know how you can proceed. Because ultimately, if you grow, we will grow. Come, India will grow. Okay, so something like that. So is there any question from your side? If someone have the any questions, you can raise. Okay. Okay, but what kind of tools exactly you're talking about? Okay, for robotics. See, for robotics, initially you have to learn the basic structure of that. Like as I told you, for you have to first initially find the problem what you exactly want to solve. Okay, because robotics is a huge domain. In which domain you want to solve? Like you want to solve the problem in industry sector, or you want to solve the problem in medical sector, in defense sector, and social sector, underground sector. There are lots of sectors in robotics. First, you have to identify the problem. Once you get the problem, then you have to think what kind of application you are going to do. Okay, after problem, you have to find applications. Like in suppose I'm talking about the medical robotics. You know, you are going to contribute your robotics knowledge in the medical domain. But in medical domain, there are lots of, again, few branches are there. In medical domain, what exactly you want to do? Suppose, as you know, one company in you can say France, they have developed a robot called Da Vinci. I think you have all heard. It's available in the internet also. Da Vinci actually is a robotic surgery robot. Okay, that robot is used to means that robot can, you can say, remotely do the surgery. If the doctor can sit in the some, you can say, gesture mounted computer system where he has to wear some uh, rings over their finger. Only he has to remove the finger, that is gesture mounted. And what you will find, the patient who is lying in the bed, in front, in the top of that patient, you will find a robotic arm, that is cobotic, you can say, not robotic, so cobotic arm. There are two arms are there. In that two arms, you will find multiple tools are attached, like a scissor is there, drilling is there, lots of things are there. If the doctor is moving the finger in 0.01 mm, that gesture will, again, you will find to see in that robot. Means it's like a wireless communication. Means whatever the doctor is moving the finger, the robot will move. So this is kind of remote surgeon, you can say. Like what happened if some doctor is sitting in the US and they want to do the surgery in the India, they can do like that. So it's a completely IoT based. And when the doctor in the robot is there is a camera mounted over the wound what they are exactly doing for the surgery purpose, that the doctor can observe the wound and easily move their fingers. And in the you can say patient side, the robot is doing the same thing. In the YouTube, I think you'll get these videos also. So means and that is not exactly for the remote purpose, that is also for accuracy. I mean, that robot is that much accuracy that which can peel off the skin of a grapes. Okay, that robot took one grapes. Okay, that grapes skin, that robot can peel, and again that skin is peeled again. That robot is they did the stitching of that particular skin of a grapes. So that much accuracy it's that robot is having. Even the human cannot do that kind of high level surgery. Okay, for tools, if you want to learn, focus on the ROS, as I discussed. Once the problem is solved, you have to check the hardware part. Hardware means, as I told you, for robotics, you have to choose servo motor, learn about servo motors. It's open source, available in Google everywhere. Okay, because in particular hardware, there is no such thing like that. And once you choose the motors, you have to choose the controller. From as a better point of view, I will suggest you can choose a Raspberry Pi for the best option, because Raspberry Pi is having there is no limitations in Raspberry Pi. Use that particular board, that because in Raspberry Pi you will find lots of resources in the market, as of from your college point of view. Choose Raspberry Pi. Okay, do take some servo motors in different payloads. It doesn't matter. You have to go for the heavy duty motors. First, test it on your work days. Then choose a platform like a ROS. ROS is an open source platform. You can choose ROS. Okay, ROS is a completely open source. If you can go through the ROS website, it's a huge platform, huge. Just start with the single modules. Initially, what just start with some sensors. Take one sensors and one motor, and take one Raspberry Pi. Then observe the what are the changes you will find in the motor if you give some input to the sensor. Slowly you can change the, you can add one more motors, again two more motors, like that. First start with one motors, then go to the two and three motor, maximum three. Once you are used to get some particular data from the three motor, like that motors are independently moving in a synchronized way. Like if you are going putting X to the X motor one, Y to the motor two, and Z to the motor three. If you can see, if I'm moving X, the motor one is moving. If you're doing some change in the Y, motor two is moving. If you're doing some changes in the Z, motor third is moving. Once you see this changes, it's your up to your satisfaction. Then you can create one mechanical structure. Okay. Then what happened? Then you will call it as a three axis, you can say industrial robot, but make it in a small project like that. No need to go for the huge motor, because that if you're going for the industrial grade, that cost huge, because that motor cost, one single motor cost around 20 lakh rupees. That is a huge thing. But focus on the small servo motors. Take in the market, you will easily find the 500 1000 rupees. They are easily available in the market. Choose Raspberry Pi servo motor and take one platform. Whether you can choose ROS, that is the best option what I suggest. Okay, so this thing is enough. If you want to add some sensor also, that is the additional part, but no need to add sensors. First, control that servo motor using your Raspberry Pi, and input will be given from your server. Okay, so this, from there you can start learning. There are huge things available in the internet, because in your age, in generations, you have all Google, you have, so that is one of the, you can say, great teachers as of now. Clear? So in this way you can start and start tinkering. Then also get some idea what exactly happening in that industry, because ultimately after your graduation you have to head to the industries. So from now, just focus on the challenges what industry is having. Okay, so initially start with some tinkering purpose, but don't get that much focused with the tinkering. Okay, because see, robotics is that much fascinating subjects. People is used to get that much uh, intention that they used to play with the robots and all. Always, whatever you are going to make a project, whether small or big, it should be focused on the industry point of view. Means with your project, just try to solve any problem, any challenges of the industry. Because if you are not going to do that, your project will be like a just like a toy. In nowhere you won't get any appreciation, anything from anywhere. So just focus on the problem from the industries. Talk to the people, those who are working in industries, they will tell you the problems exactly. And how can you solve that problem using the robotics? That can be your achievement in some day. Because even in your CV, you can write that I have designed and developed one device which is used to solve that particular problem in the industries. So that will really help in your placement and in your, you can, future career. Okay, so is there any further questions we would like to talk? So shall we close, or I'll wait for some questions?
I think that was all from our audience side.
Okay.
Thank you, sir, for joining us today and giving so much information about cobots and everything that we are like, about robots and all. It was very interesting to watch those like cobots doing that stuff, and yeah, and videos were also interesting. So yeah, thanks for that wonderful session. Yep.
Okay, Rishabh, thank you. So all the best for all of you.
Thank you, sir.
Okay.